This was my perfectly good Panasonic microwave oven that I had an extra of, and I decided to turn it into a UV curing system. So what I did was paint the inside with metallic paint. You can get mirror paint. I used aluminum paint. I then took out the magnetron. So I ripped out all the guts, and this was spot welded on. So I used a cordless drill and I drilled out the spot welds. And then I 3D printed this part in PETG. You could also use ABS. And designed that in Fusion 360 so that I could take a genuine 100 watt, 405 nanometer light source and make it fit into that spot. I then bought this heat sink with an 80 millimeter fan, and I used thermal CPU paste to thermally couple it to that heat sink. I got a 3000 milliwatt LED driver, and then I just got a typical 12 volt power supply to power this fan. And at first I tried to have the built-in timer work, but the problem I ran into was that it wouldn't run unless it got a pulse width modulated signal from the magnetron's inverter. And that would be way too much work to try to duplicate that signal and trick it into working. So I cut all the wires off it, and I hardwired everything to the main power coming in. So that is powering this AC fan. Under here, there's the turntable motor, which is also AC. This runs off AC, and this runs off AC. So you simply splice everything together, and then you buy an external timer, and it works with the door on. The door can be open or closed. You can see it rotates and the light is on. And this fan is very powerful, and that fan is very powerful, but I did put in a temperature probe, and it doesn't get very hot. You need to keep that below 60 degrees Celsius, and it seems to stay below that. So I am not sure how fast this cures yet, but 100 watts in this small amount of space is a lot of power. And I actually used a kilowatt meter and verified it was drawing 104 watts. That includes some power supply losses, but it is an actual 100 watts. So it should be quite powerful. And this should beat a form cure, and it has a lot more space. I am going to fill this up with over 100 parts at a time. So I'm quite excited about it, and it was not hard to do. This was like $25. The emitter was about $45. This was, I don't know, something like that. Altogether, they came to something like $97. And that's not bad when you think that it's a real 100 watts and not a fake 100 watts like so many LEDs are. This microwave I had lying around, so it was free, but you could just get one of those at the dump. People drop off old ones and go grab the largest one you can find and make one of these. Look in the link below the video, and I will give you some links to the various parts that I had to get.